6b, multiplication of fractions. So now we're going to look at multiplying fractions. Now, as I said in a previous video, multiplication and division of fractions is actually easier than addition of fractions. And what makes it easier is the fact that we don't need a common denominator. To multiply fractions, all we have to do is multiply. So let me show you this, and I'm going to show you a visual first. I'm going to say, well, what if we have 1/2 times 3/5? Now let's look at this graphically and see what we can do. So if you're talking 1/2, let's say I take this rectangle here and I split it into halves. Right? So if I split those into halves, I can say, okay, that's 1/2 of this rectangle. I want to multiply that by 3/5. So what I'm going to do is I'm going to break this into 5 pieces the other way. 1, 2, 3, 4, 5, right? 3/5. So I'm going to color in 3/5 of those. 1, 2, 3, right? So there's 3/5 of those colored in. Now, what I'm going to do is I'm going to look at these and say, okay, well, which ones were colored in by both 1/2 and 3/5? Well, that's this one, and this one. Right? Those are the ones that were colored in by both the 1/2, they're part of the 1/2, and they're part of the 3/5. Now, if I look at that, that means now what's the colored in fraction? Colored in with this reddish, looks purple with this going through all that black and blue. But if I look at that, I see I've got 1, 2, 3 out of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3/10. Now let's look at what we do with multiplication of fractions. I've got 1/2 times 3/5. When we multiply fractions, all we have to do is multiply the numerators. 1 times 3 is 3. And multiply the denominators. 2 times 5 is 10. And we get 3/10, which is exactly what we saw visually by making it 1/2 by 5. Just multiplying or taking those portions. So that's what makes multiplication of fractions simple, is all we have to do is multiply the numerators, multiply the denominators, and then simplify if possible. So let's do a few of these. Four ninths times 3/7. 4 ninths times 3/7. We do not need a common denominator. In fact, if you do go through the work of creating a common denominator, you're just making a lot of extra work for you because 1, you have to take that effort to find a common denominator. And then 2, when you get to the end, you're just going to have to simplify it back out again. So you're creating extra effort for you. So all we have to do is multiply across. 4 times 3 is 12. 9 times 7 is 63. We have 12 63rds. And we need to simplify if possible. Well, I remember divisible bys. 1 plus 2 is 3. 3 is divisible by 3, so the numerator is divisible by 3. 6 plus 3 is 9. 9 is divisible by 3, so the denominator is divisible by 3. So I'm going to divide both of them by 3. 12 divided by 3 is 4. 63 divided by 3 is 21. So you get 4 21st. That wasn't so bad, was it? If we were adding or subtracting, we would have had to find common denominator and put the work into that. But in this case, we did not. Well, let's take another one. Three eighths times 4/8. So 3/8 times 4/8, common denominator. Do we care? No. We're not adding or subtracting, we are multiplying. And multiplying, we're going to multiply across the numerator, we're going to multiply across the denominator. So 3 times 4 is 12, 8 times 8 is 64. 12 and 64, they're both divisible by 2. In fact, they're both divisible by 4, so I'm going to divide both by 4. 12 divided by 4 is 3. 64 divided by 4 is 16. And we get 3/16. So, again, not that bad. It's actually easier to multiply fractions than it is to add or subtract. And this is probably the only case in mathematics where it's easier to do multiplication and division than it is to do addition and subtraction. Generally, addition and subtraction are the easier operations, but not with fractions. Alright, so let's try another one. What if we have 6 25ths times 15 18ths. Okay, so we got 6 25ths times 15 18ths. Now, I'm already looking at this and going, 6 times 15, that's not so bad. 25 times 18, that's bad. It's not bad, but what it is that just looks like it's going to give me a large number. And it is. 25 times 18, every 4 25s is going to give me 100. So this is going to be 450. Six times 15, that's 90. Now I've got to reduce. Well, I see zeros, so I can divide both the numerator and the denominator by 10, which gives me 9 45ths. And then I also see that 45 is divisible by 9. So 9 divided by 9 gives me 1. 45 divided by 9 gives me 5. And I come out with 1/5. Okay, well, that wasn't necessarily the easiest multiplication for me to do. That simplified pretty easily, so that wasn't too bad. But what I want to show you now is a slightly different approach to this. Notice that we did our multiplication, then we simplified, worked our way down. Now, some of us may have noticed things going on here, like the fact that 15 18ths is able to be simplified, right? 15 and 18 are both divisible by 3. So what I could have had, 6 25ths, nothing I can do to simplify that. So if I keep that as 6 25ths, and I simplify this and I go, hey, I can divide 15 by 3, I can divide 18 by 3, 15 divided by 3 is 5. 18 divided by 3 is 6. And I go, okay, well that's much easier. 25 times 6, I like that much better than 25 times 18. Now some of you may notice, well wait a second, Mr. Davis. I see a 6 here and a 6 here. Well, think about it, when we multiply fractions, don't we just multiply the numerator and multiply the denominator? So once we do that, aren't they essentially over, so isn't this the same as saying 6 times 5 over 25 times 6? And doesn't the commutative property tell me I could rewrite that as 5 times 6 over 25 times 6? And then if I were to reverse this process of multiplication, couldn't I say that's equal to 5 over 25 times 6 over 6? Now I'm just using this red to show what we could do with some manipulation here, which puts us into a position to notice that we can, at any time, once we're multiplying, we can say, well, wait a second, 6 divided by 6, well, 6 divided by 6, that gives me 1 and 1. I could cancel out those 6's. 5 and 25, well, those are both divisible by 5. I can take that 5 and turn it into 1, and I can take this 25 and turn it into a 5. Now I have 1/5 times 1/1. You don't use the term 1th very often, which gives me 1 times 1 is 1, 5 times 1 is 5, 1/5, which is what we found here. So it is possible at times for us to simplify earlier on. And if we can do that, then it can make our life easier or simpler when we do our multiplication, because if we could simplify here, then we're gonna have to do it over here. Whereas if we do the simplification first, then our multiplication is simpler, and we may not have to do any reduction in the end. Okay, now previously we talked about reciprocals for fractions. Well, one cool thing about fractions and multiplying is if you multiply a fraction by its reciprocal, you get 1. So if I take a over b and multiply it by the reciprocal of a over b, remember we said that this -1 as an exponent turned this into the reciprocal? Then that's a over b times b over a. Right? The reciprocal is just flipping the numerator and the denominator. Well, multiplying across, that's a times b over b times a. Commutative properties of multiplication says I can swap the order. So a times b divided by a times b. Well, I've got the same thing on the top and same thing on the bottom. That's 1. I know you don't like the variables. That's okay. You'll survive. But all I'm showing here is that if you take a fraction and multiply it by its reciprocal, that you will get 1. And we can see that easily enough by doing a quick example. If I take 2/5 and multiply it by 5/2, its reciprocal, then 2 times 5 is 10. 5 times 2 is 10. 10 divided by 10 is 1. So anytime you take a number and multiply it by its reciprocal, you get 1. And that's called the multiplicative identity. That a number multiplied by its reciprocal is equal to 1. Multiplicative inverse is that a non-zero number and its reciprocal are multiplicative inverses. Okay? So if I have 1/7, then its multiplicative inverse will be 7/1, or 7. If I multiply them together, 1 times 7 is 7, 7 times 1 is 7. is equal to 1. So if you take any two numbers that you can multiply by each other and you get the result of 1, those two numbers are multiplicative inverses. Now something else I'd like to point out, because it starts to fit into this, and I believe I mentioned this in an earlier video, is the relationship of negative fractions. If I have negative a over b, that is the same as negative a over b is the same as a over negative b. Those are all the same thing. Remember, a fraction is just division, right? So if I divide two numbers with opposite signs, the result is going to be negative. If I divide two numbers with opposite signs, the result is going to be negative. So therefore, if I have the negative of the division of two numbers, or of a fraction, that negative sign can be placed either in the numerator, in the denominator, or in front of the fraction itself. Meaning, if I have negative 3/4, that is the same as saying negative 3 over 4 is the same as saying 3 over negative 4. And that becomes very powerful when dealing with fractions and negative signs, because we can move them around to make our life easier as we continue on with other operations. And there's multiplication of fractions.